Welcome to statics. This is a good, simple, elementary problem to help you learn how to solve a truss. All right, so to begin with, for these kinds of problems, when it says solve the truss, you basically have to begin by getting those external reactions. And so to do that, I'm going to make a simplified diagram over here, where I am just going to outline the truss, and I'm going to solve for my external reactions. So we have a 100-pound force doing that. We have something going on here at E. We have something going on here at A. A is a pin. And so pin can provide support in both the X and the Y. And I'm going to guess that AX is going that way because I can see that the 100-pound force is going that way. All right, and now I'm going to make another guess that E is holding up the truss. I'm going to guess that E, of course, E can only push up because it's a roller. I'm going to guess that that's up, and as soon as I guess that that's up, AY has to be down because it has to. These forces have to offset one another in the X and Y direction. Okay, so now let's apply the equations of equilibrium. Sum of the forces in the X direction, set them equal to 0. We get 100 minus AX is 0. Therefore, AX is equal to 100. We are in units of pounds and feet. We're going to sum the forces in the Y direction, set them equal to 0. And so what we get is EY minus AY is 0. And so once we get one or the other, we will be able to solve the problem. And then the last thing I'm going to do is I'm going to sum the moments at A and set them equal to 0. And pay attention to your signs here. So we're going to have a minus 100 times 2 plus EY, whatever it winds up being, times 2. Therefore, EY equals 100. And yes, it's up. And therefore, AY is 100 down. Okay, so we have our external reactions, and that's a great beginning. So now the principle of solving a truss is you work your way around the truss and you just start from someplace that makes sense to you. So I'm going to start by at pin B, and you'll see why in a second. So tell me what you're doing. Whoever is grading your work, you need to kind of identify what pin you're talking about. So pin B has a 100-pound force doing this. It has some force going off in that direction that will be BC. And then it has some force coming down that will be AB. And that's all it's got. And so it doesn't matter which way I put the arrow on AB. As soon as I sum the forces in the Y direction mentally and set them equal to 0, I can immediately conclude that AB is 0. And putting a double hatch on the segment is my way of indicating that that is a 0 force member. So AB is a 0 force member. And we can start summarizing our answers off on one side, which is good form. So we have found that AB is 0. Now, likewise, let's go ahead and sum the forces in the X direction, set them equal to 0. I must put an arrowhead on BC. It's kind of clear to all of us that it's going to be going in that direction. That is to say that member is in compression. And so what I find is I have the positive 100 minus BC is 0. Therefore, BC is equal to 100 compression. And let's record that off over here. So we found that BC is equal to 100 compression. So I want to take just a moment over here on the side to talk about compression versus tension. Students are very confused by this at times, and so I hope that this will help you think about it. So back there on pin B, right, pin B was feeling this 100-pound force. It was feeling nothing this way, and we decided it was feeling 100 from force BC. So that's what the pin was feeling. Let's think about the member now. So the member BC, right, we're just taking a chunk out of the middle of member BC. In other words, out here on BC, what I'm saying is let's just take a slice out here in the middle of BC and let's consider what's going on. So here I am, this is the slice I took out of BC, and I'm considering to myself, all right, what's going on in that member? And so remember, when we take things apart, right, because this is an internal force, this 100-pound force is an internal force, I must reverse the direction of that internal force. And so that means when I reverse that, right, I reverse that, I get that. That means that this member is feeling a compressive force. And so we can extend that concept to there. When we go out to pin C, this is what pin C is going to be feeling from that member BC. So that is why when the arrow points in toward a pin, that is why the member is under compression. Okay. So let's move on now to another pin. Let's go to pin A. All right, so here's what pin A's got. Pin A, it has this AX, which we decided was 100. It's got an AY, which was 100. It has this force AB, which we decided was 0. It has some force going off in the AE direction, and it has that's AC, and also has this going off here in that direction, so it has an AE. So we must assign directions to things. So looking at the Y direction alone, I can see that AC must be going that way. I don't know in what direction to put AE. Let's just put an arrowhead going that way for now. And so let's sum the forces. Let's apply the equations of equilibrium. Let's sum the forces in the Y and set them equal to 0. And as we do that, we see that 0 will equal minus 100 plus, we're going to have the 1 over square root of 2 times AC. And therefore, AC is going to equal 141 tension. Why tension? Because it's pointing away from the pin, and that ends up signifying that the member is under tension. And when we sum the forces in the x direction and set them equal to 0, I get minus 100 plus AE, whatever that is, plus 1 over square root of 2 times 141. Well, this is actually 100, and so therefore AE is equal to 0. And so let's record some of these values up here where we should be monitoring what we're doing. So we have found that AE is equal to 0. We found that AC was 141 tension. And if we return our gaze kind of back onto this truss and have a look at things, I'm just going to outline some of the things we know. We have found that AB is 0. We found BC was 100 compression. Okay. We found that AE was 0, and we found that AC was 141 tension. So let's turn our attention to a new part of the truss. Let's go maybe, I don't know, pin C. All right, so pin C, let's do this pretty quickly because I am going to hit my 10-minute mark. Pin C, you have the 100 coming in, you have 141 coming away, you have the 100 coming up, and you have CD going off that way. When you sum the forces in the x direction, you find that CD is equal to 0. So that was pin, where were we? That was pin C. And I'm definitely going to hit the 10-minute mark, so I'm going to call this part 1 of simple truss, and part 2 will come.